Hello, hello, you lovely people. I hope you're all doing well. If you're not, you soon will be, because we're going to do some more chemistry. Today we're going to have a little look at the alkanes again and really focus in on naming and drawing our alkanes. So what's our learning intention for today? Well, today we're going to use a systematic approach to naming and identifying different alkanes. We'll be using the naming prefixes that we learned in last video, meth, eth, prop, etc. And as I said, we'll be using a kind of systematic approach to draw and name more complicated alkanes that have branches within their chains and structures. Okay, let's start off with a couple of easier examples, and we're going to use the knowledge that we learnt in the last video to have a go at naming these simple alkanes. Now, the first thing you want to do whenever you're given a structure like this and you're trying to name the molecule, you want to count how many carbons there are first. That's the first step that we need to do. So let's have a look at example number 1 here, and we can see that there are 1, 2 carbons. And if we cast our mind back to last video when we talked about our prefixes for the number of carbons, hopefully we can remember that when we have 2 carbons, then the prefix is eth. And as I said last time, we need to remember the first 8. We need to remember from meth, eth, prop all the way down to oct and the equivalent number that each prefix stands for. So back to this example, then we see that we've got 2 carbons, and if we've got 2 carbons, we should know that the prefix is eth or eth. Now, we've only come across one homologous series so far, the alkanes, so we know the ending is going to be ANE. However, we're going to learn a lot more, so we need to know and to remember why this molecule is an alkane and why we're putting in the ending ANE. So how do we do that? Well, there's a number of ways we can do it. Quite simply, we can look at the type of bonds that this molecule has. It's only got single bonds, so it's a saturated molecule, so it should be an alkane. There's no double bonds here, it's only single bonds. That's a kind of quick and simple way to determine it. The proper way would be to get the molecular formula for this molecule. It's C2H6, and that corresponds to the general formula CnH2n plus 2, which we know that if we have this general formula for any compound, then it must be an alkane. Now those are the basic steps in naming a simple structure like this. Let's kind of put all that together now and have a little look at question number 2 here. First things first, we look at the number of carbons. We've got 1, 2, 3, 4 carbons. 4 carbons, well, the prefix must be but. I have a little look at the types of bonds. It's all single bonds. It corresponds to the general formula CnH2n plus 2, so it must be an alkane, so it's going to be but, and then the final 3 letters are ANE. So we've got this molecule is butane. And the third example now, well, I've drawn it a slightly different way. These molecules are able to be rotated in three-dimensional space. They don't always have to be drawn in a line going this way. They can draw going down the way, going up the way. They can even be drawn as a kind of squiggly line as well. So we need to get comfortable and used to seeing these molecules in different orientations, but the process is still the exact same. We look at the number of carbons. We've got 1, 2, 3 carbons. Well, the prefix for 3 is prop. I look at the type of bonds. It's only single bonds. It corresponds to CnH2n plus 2, so it must be an alkane, and it's going to end in ANE. So here we go. We've managed to name these 3 quite simple alkanes. What we're going to have a little look at today is continue this kind of naming process, but have a little look at when the structures get a little bit more complicated and have structures like branches within them. And just before we get into the more complicated ones, let's make sure that we're comfortable with doing the reverse process as well. So if we were given a name this time instead of the structure and we wanted to draw this alkane. So we have a little look at the name. We've got the prefix pent. That tells us that we must have 1, 2, 3, 4, 5 carbons. We have a little look at the last three letters. It tells us it's an alkane, so the general formula is CnH2n plus 2. So we can use that to figure out how many hydrogens we're going to have to put on this alkane. We know that we've got pent, we've got 5 carbons, so when we've got 5 carbons and we do the little sum here, we must also have 12 hydrogens. So we can go in and stick on our 12 hydrogens. That's one way to do it, but if you remember from last day, I said this kind of chemistry is pretty much like counting to 4. And as long as we remember that each and every carbon must have 4 bonds or 4 lines coming off of it, then we can just kind of go ahead and fill in the lines like I've done here to make sure each carbon has 4 lines, and then we can put in our hydrogens. Hydrogens only make 1 bond, carbon make 4, and so if we make sure all our lines now have hydrogens on the end, it'll work out to have the correct chemical formula C5H12. We can check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, 5 carbons. There we go, there's pentane. Let's have a little look at that with just one more example. Let's say we wanted to draw propane. Let's do the exact same thing. We've got our prefix prop, means we've got 1, 2, 3 carbons. I know that every carbon wants to have 4 bonds. Well, this one's only got 1. There's a bond there. So let's put in 1, 2, 3 more. So this carbon now has 1, 2, 3, 4 bonds. And on each of the empty bonds, we'll pop in our hydrogens. Now let's go on to the second carbon. It has 1, 2 bonds, so only need to put in another 2. And the hydrogens attached to that as well. And then I'll do the exact same thing with the last carbon, putting on the 3 missing bonds and the 3 missing hydrogens. I can count all this up now. I've got C3, count up my H's, 1, 2, 3, 4, 5, 6, 7, 8, C3H8, and that is the chemical formula for propene and the structural formula as well. So not all of the structures that we come across are going to be nice, simple, straight-chained alkanes. More often than not, they're going to be structures like this one, which is a branch-chained alkane. Now, what do we mean by a branch-chained alkane? Well, if we look at the structure here and we have a little look at this part of the structure, we've got an extra carbon that is branching off of this main carbon chain. Now, this is called a branch, and to be more specific, since it's got 1 carbon in it, and we think back to our prefixes for 1 carbon, the prefix is meth, this is called a methyl branch. That's the name of it. It is CH3 and it's called a methyl branch. Now there are other types of branches as well, not just methyl branches. If we had, let's say that's our straight chain of carbons and hydrogens, and we had a branch coming out that had 1, 2 carbons on it and 5 hydrogens. Now this branch here would be called an ethyl branch. Remember, our prefix for 2 carbons is eth, and if it's a branch it gets the ending YL, so it's pronounced ethyl, and this would be a C2H5 branch. 99% of the time we are going to come across and work with methyl branches. Occasionally we'll get an ethyl branch, but most of the time it's going to be methyl branches. And if you had, on a very, very, very rare occasion, you had a branch with 3 carbons on the branch, then that would be a propyl branch. However, this is very, very rare and do not come up often at all. But it's worth just going over and just to be familiar with it. That would be a propyl branch right there. But as I said, we're going to really be working today with just methyl branches because they're the most common ones. So let's say then that we were given this structure here and we were asked to name it. Now it wouldn't just be as simple as looking at the number of carbons and then writing down something like pentane. That would be wrong because pentane would be 5 carbons in a straight line. This has 4 carbons in a straight line and a branch. So we're going to have to go through some steps here to get the correct name. So let's have a little look at these steps then. So, in order to name a structure like this, the first step would be to find the longest chain of carbon atoms. Now we've got a couple of options here on the longest chain. We could say this is the longest chain, 1, 2, 3, 4, or we could start here and go 1, 2, 3, 4, or we could start here and go 1, 2, 3. Well, it's not going to be that one. Let's just use the kind of easiest one to look at. Let's go across this way. So we'll go 1, 2, 3, 4. Now that's our longest chain of carbon atoms. That's our first step done. Now what does that tell us once we've done the first step? Well, it tells us that since we've got 1, 2, 3, 4 carbons in our straight chain, the straight chain is going to be called bute. That's our prefix for 4 carbons. 1, 2, 3, 4, bute. Now to get our ending, we look at the type of bonds we've got. We can look at the general formula. This molecule would fit into the general formula CnH2n plus 2. It must be an alkane, so it's going to be butane. Now what we've done currently is we have named this section here. That's what we've named. However, we have not named the branch yet. So we're going to have to do that. We're going to have to name the branch. So we've got this first part done, butane. Step number 2 says number the chain, making sure the branches have the smallest number. So what does that mean? Well, here's our straight chain that we've already identified as butane. I've numbered it already, but I could have also numbered it going the opposite direction. Instead of saying this is carbon number 1 and this is carbon number 2, I could have started numbering it here and went 1, 2, 3, 4, like that. Now it's important that we choose the correct numbering system at this stage. Let's just reread this step. Number the chain, making sure the branches have the smallest number. Okay, if we look at the green numbers here, well, if I number it going from left to right, that branch is on carbon number 2. If I number it from right to left, that branch is now on carbon number 3. So since 2 is obviously smaller than 3, this has to be the correct numbering system. The one in green has to be the correct numbering system, going from left to right. The red numbers don't allow us to have that branch in the smallest possible number, so we're just going to remove those numbers. So we've named the longest chain. We have now also numbered the chain in the correct way to make sure that the branches are on the smallest possible number. Now we're going to go into step 3. What type of branch do we have? Do we have a methyl branch, ethyl branch? Well, our branch only has 1 carbon in it. There's only 1 carbon, so this must be a methyl branch. Has to be a methyl branch. So now I can write that in front of the word butane. And when we're naming these branch chained alkanes, it's almost like we write the name backwards. We kind of start with the end and write backwards, which is a little bit unusual, but it's probably the easiest way to do it. So we've identified the type of branch. It's a methyl branch. Done that step. Step number 4, if we've got more than 1 branch, we need to tell the reader who's ever reading the name that we have more than 1 branch, but in this case we've only got 1 branch, so we don't really need to do step 4. We'll show an example of that later. And then step number 5, number the position of the branches or branch. Well, we've already numbered our straight chain and we know that the branch is on carbon number 2, so this would be 2 dash methyl butane. That would be the name of this structure here. Now I appreciate that's quite a lot of information and it's kind of quite confusing at this point. However, trust me, see, once we've got a couple of examples under our belts, it's a lot easier and it makes sense. So with that said, let's look at some more examples. Now we've got another branch chained alkane, another branched compound. Let's go through our steps again. First step, find the longest chain of carbon atoms. Well, got a couple of options again. I can go 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I could go back the way and go 1, 2, 3, 4, etc. Looks like 5 is going to be the longest chain, and for ease sake, let's make it this middle chain here. We could have also went down the way as well and made this 5, but just for ease sake, I'm going to take the middle chain. So then our longest chain of carbon atoms contains 5 carbons, therefore we're looking at pent. When we've got 5, our prefix is pent. We know it's going to be an alkane as well because it's only got single bonds. So it's a saturated molecule, it's going to be an alkane. And if we counted up the number of carbons and hydrogens, it would also fit into that general formula CnH2n plus 2, again telling us that this is an alkane, so it must end in ANE. What we've done right now is we've done step number 1, and we have looked at the longest chain of carbons and we've named it. Next we need to have a little look at step 2, and it says number the chain, making sure the branches are on the smallest possible number. So we've numbered it this way. Let's just check to make sure that these branches have the smallest possible number. So I can number it from left to right, or I can start here and go 1, 2, 3, 4, and 5. Let's check the numbers of these branches to see which numbering system we'll use this time. Going on the blue numbers from left to right, we've got a branch here on the 3rd carbon, and again using these blue numbers we've got a branch here on the 4th carbon. However, if we use the red numbers instead, we would have a branch on the 2nd carbon and the 3rd carbon. So 3 and 2 is obviously smaller than 3 and 4, so we need to use then the red numbering system this time, going from right to left, not the blue numbering system from left to right, because this allows us to have our branches on the smallest possible number. So there we go, we've removed the wrong numbering system and kept the correct one. So that's us done step number 2. We have numbered our longest chain of carbons to make sure that the branches have the smallest possible number. Step number 3 then, we're going to look at the type of branch that we've got. Well, each branch only has 1 carbon, and they both are methyl branches. If they had 2 carbons in them, then it would be ethyl, but they've only got 1 carbon in them, so we've got 2 methyl branches. Done that step. Step number 4 is one that we didn't look at last time, and it's important here because we've got more than one branch. We need to use some more prefixes to indicate how many branches we have. So we know that we've got methyl branches, and we've got 2 of them. So in chemistry, just like when we talked about diatomic elements to mean that they've got 2 atoms in them, we're going to use that word, that prefix di again here, to indicate that we've got 2 methyl branches. So we need to say di for 2, methyl for the type of branches that we have. So we've got here dimethyl pentane. Now I'm slightly running out of room here because I need to put some numbers in front of this name, so I'm just going to move it up over here just to give myself a little bit more room. Like I said, we almost write these names kind of back to front, starting with the pentane, then looking at the methyl, and in this case the di, because we've got 2 methyl branches. The last step that we need to do, step number 5, is number the positions of these branches. Now, using our number system before, this is carbon number 1, this is carbon number 2, we have got a branch on carbon number 2 and carbon number 3. So what we would do here is go 2, 3 dash dimethyl pentane, and that is our final name for this molecule here, 2,3-dimethyl pentane. Let's just go through it. The 2 tells us that we've got a branch on carbon number 2. There's carbon number 2, there's our branch. What type of branch is it? Methyl branch. We've got another methyl branch, so we've got two of them, that's why we put the di in there. Another methyl branch on carbon number 3, and then our longest chain has 5 carbons in it, so it's pent, and this is an alkane, so we end with ANE. Again, quite complicated stuff there, but once we get through a couple of examples, it really does start to make sense, and it's just remembering these steps, remembering the process. Okay, let's have a little look at a third example here and go through our steps in order to name this branch chained alkane. First step is to find the longest chain of carbons. A couple of options as always. 1, 2, 3, that's not going to do it. 1, 2, 3, that won't do it either. 1, 2, 3, 4, 5, 6. That's looking a little bit better. And we could go 1, 2, 3, 4, 5, 6 as well. Let's just choose the center chain for ease sake. So we've got 6 carbons in our center chain. Our prefix for 6 is hex, like a 6-sided shape, and we know this is an alkane as well, so it's going to end in ANE. So we've got hexane, and what we've done as usual is we've named that center part here, the longest chain. We still have to name and identify our branches as well. So step number 1 is done. Step number 2, we want to number the chain to make sure that these branches have the smallest possible number. So we could number it from left to right, and it would be 1, 2, 3, 4, 5, 6. Or we could number from right to left, which would give us 1, 2, 3, 4, 5, 6. Only one numbering system is correct, and it's a green numbering system, because that allows us to have these 2 branches on the smallest possible number. If we use the green numbers, these branches are on carbon number 2. If we use the dark blue numbers, however, then these branches would be on carbon number 5, and that wouldn't be correct. So then that's step number 2 done. Step number 3, what type of branches have we got? Well, as usual, we've got methyl branches. Let's just identify them. They've got 1 carbon in them, CH3. These are methyl branches. Number 4, well, we need to indicate how many methyl branches we have. We've got 2 methyl branches, so we'd use the prefix di. And let's put it in front of our hexane now. We have got di 2 methyl hexane. And our last step is we number the position of the branches. We've got 1 branch on carbon number 2, and we've got another branch on carbon number 2 as well. So we need to make sure that we number both, and we say 2, 2 dash dimethyl hexane. It's important that we put both 2's on, even though they're on the same carbon. Each number is just for 1 branch. Since we've got 2 branches, we're going to have 2 numbers on it. And there is our third example done. 2,2 dash dimethyl hexane. Well, now this next example is an example of a question that people get wrong quite a lot, and because they kind of rush into it and they forget some of these important steps. Now, what a lot of people would do when faced with this structure here is would do something like this. So we'd go, okay, there's the longest chain, 1, 2, 3, 4, must be butane, and oh, here we've got an ethyl branch because we've got 2 carbons in it, so it must be ethyl butane, and it is on the second carbon, so it must be 2 ethyl butane. Now that would be wrong, that's not the correct name for this branch chained alkane. Can you spot what mistake I've made there? Yeah, well done if you've spotted it. What I've done is I've totally forgot to do the very first step. The very first step is oftentimes the most important step. Find the longest chain of carbons. 1, 2, 3, 4 is not the longest chain of carbons here. It is 1, 2, 3, 4, 5. That first step is very important, and oftentimes you get structures like these drawn in this manner deliberately to confuse you. So make sure we always do that first step. Deliberately find the longest chain of carbons. So what would the correct name be? Well, once we've got the correct longest chain and we've popped in our numbering system, we see now that the longest chain has 5 carbons in it, so it would not be bute, it would be pent. It's an alkane, so it ends in A-N-E, so we've got pentane. Now we need to name our branch. It's a methyl branch, so we've got methyl pentane. And what carbon is it on? It's on carbon number 3, so 3 methyl pentane. This time, if we number it from I suppose from high to low or low to high, it doesn't really make any difference in terms of what number this branch is on. It's always on carbon number 3. So that's just us checking our step number 2 there. And here's the correct name for this structure, 3-methyl pentane. Right, let's look at our final example here. Go through our steps. Longest chain of carbons appears to be 1, 2, 3, 4, 5, 6, 7 carbons. So that means this structure is going to start with hept, and it's obviously an alkane, so it's going to be heptane. I know it's an alkane because it's only got single bonds and it falls into the alkane's general formula. Done step number 1. Step number 2, I need to number the chain to make sure that these branches have the smallest possible number. So we've got a couple of options here. As usual, we can go from left to right or right to left. Let's check it out. If we go from left to right, we allow these branches to be on carbons 2, 3 and 4. If we went, however, from right to left this time, starting here, carbon 1, 2, 3, 4, 5, 6 and 7, well, this time we've got branches on 4, 5 and 6, which is obviously bigger than 2, 3, 4. So the numbering system must be the bottom one, the green one, from left to right. There we go, we've done step number 2 now as well. Types of branches, well, we've got this time 3 methyl branches. I know they're methyls because they only have 1 carbon in them. So I've got 1, 2, 3 methyl branches. And that takes us on to step number 4. We want to indicate how many methyl branches we have. Since we've got 3, we're going to need to use the prefix tri. So it's going to be tri-methyl heptane. And let's take us on now to the last step, number the position of the branches. We've got a branch on number 2, comma, a branch on number 3, comma, and a branch on number 4, dash. And there is our final name, 2, 3, 4, dash trimethyl heptane. You always put commas in between the numbers, and you put a dash in between the number or the numbers and the words. And I think we'll end the video there today. I know, as usual, throwing a lot of new chemistry information at you. The only way, as I said throughout the video, to get good at this, to get comfortable with it, is to go through and do lots of practice yourself. And the more practice you do, the better and better you will get. Okay guys, hope to see you really soon, and take care.